All right, so let's just continue to knock out proofs. This one, whoo. All this information, all these congruent angles already marked for us, the congruent side as well. Let's just be a tad lazy. Don't tell anyone I did this. We're just gonna put an arrow there and write given. All right. Now what I like about this problem is that we get to practice writing a congruency statement, triangle A, B, C. Well, A corresponds to D, B corresponds to E, and C corresponds to F. So this is an incredibly easy problem. All right, you guys are spoiled rotten. Whoever made this problem put all the tick marks on for you, basically gave you all the information, even told you it was angle, angle, side. And then the last part, the punchline is, well, hold up, we never said anything about AC and DF being congruent. Well, those are clearly congruent. Why? Because they're corresponding parts of congruent triangles, so they're congruent, CPCTC. All right? And we'll put a nice smiley face. Black beady eyes. Looks a little crazy. You don't know if it's gonna do anything wild. I feel like this guy might come out of the screen and haunt me. I'm a little scared of my own picture. Anyways, let's focus. All right, next one, ER is congruent to ET. ER, ET, angle R, angle T. Let's be a little bit lazy again. Again, don't tell anyone I did this. All right, and we'll write given. All right, now, all I have is an angle and a side. What else can I tell by looking at this picture? Well, out of a million times we have to get this right, a million times is we got vertical angles. Sweet, so cool. All right, little bow tie. This is kind of a weird looking bow tie, but nonetheless. So angle her is congruent to angle AET. Vertical angles. And then the triangles are congruent. I have an angle, I have a side, I have an angle. The side is between both angles, so remember this is included because it's between the congruent stuff, between congruent stuff. In this particular case, it was angles. All right, so this is angle, side, angle. All right, order of the letters are incredibly important. It looks just like how the picture is. And then remember, this one I told you, well, duh, we're using CPCTC. That's the punchline of the day. But remember, what we want to prove is always our last statement. All right, that's how proofs work. What we want to prove is always our last statement. Just think about a lawyer in court. They'd be talking about what they want to prove. All right, they're not going to talk about nonsense. Whatever we're trying to prove, that's what we're going to talk about last. All right, and we'll draw a Nike swoosh because we're cool for doing this. Nike swooshes are cool. All right, and then the last one of this video, shorter video, and we'll knock out the last ones in the next video. Given U is the midpoint, so use the midpoint. So I like to put a dot there, and then it's tick marks. JP, MP. Or PM, tick marks. All right, so again, being a little lazy, give in. Definition of midpoint, well, it's this right here. JU is going to be congruent to UM. Reflexive property, again, basically free points. Whenever we see a shared side, we should get super excited. Up is congruent to up. Then congruency statement right here, again, no angles are marked, but like J and M, those are corresponding. Then the U, and then lastly the P. And then we can say that J and M are congruent by CPCTC. All right, because they're corresponding parts of congruent triangles, so they're congruent. Since this is jump, we'll draw the Jordan jump man. Let's see how good I can draw it. Actually, this is me playing basketball. All right, Yes, I can dunk. If you guys ever wondered, the person who creates a video, can they dunk? The answer is yes. All right, that's it.